Alright, so in this class we'll be working first with the set of real numbers. So let's talk about the set of real numbers. It is broken up into subsets, and the first subset is the set of natural numbers. You might also know these as the counting numbers. And this set is symbolized by a capital N. And using set builder notation in roster form, we can list out the first few elements, starting with 1, 2, 3, and then we put an ellipses indicating that it continues in that pattern to infinity. All right, the next subset of the real numbers is the whole numbers. And this is the same set, but it adds the number 0. Next, we have the set of integers, and this is symbolized by a capital Z. And this one is continuous on both ends, and we're going to start with an ellipses, and then we'll go -3, -2, etc. Okay, next is a set of rational numbers, and this one is not well ordered, so we can't list it in roster form. We can just list examples, but we're going to first define it. And I'm going to give you an informal definition. It's any number that can be written in A over B form. Okay, so some examples of this. Of course, fractions, but also integers and whole numbers and natural numbers. Each of these are subsets of each other, but also decimal numbers. But the decimal numbers either are terminal, like 0.35, or they are repeating, like 0.3333. And I'll put a line over that last 3. And if you remember, that is 1/3 as a fraction. All right, the last subset that we're going to look at is the set of irrational. And the symbol for rational numbers is a capital Q. So the symbol for irrational numbers, we can use the I, capital I, for irrational numbers, but many textbooks use Q prime because irrational numbers are the opposite of rational numbers. An irrational number cannot be written in the A over B form. So I'm just going to write cannot. Be written in A over B form. Okay, some examples. Irrational numbers usually are in the form of a decimal that goes on forever and never repeats. But there are some numbers that you may recognize, like the number pi. Pi is considered irrational. The square root of 2, the square root of 3. In fact, all square roots of prime numbers are irrational.